Hey guys, today we are going to do a review of circles, and we're going to start with a review of tangents of a circle. Before we get directly into tangents, let's review the different parts of a circle. So we're going to draw an example of a center of a circle. So here's a circle. The center is the point right there in the middle. A chord of a circle is a segment with its endpoints on the circle. So there is a chord. A radius is a segment that extends from the center to a point on the circle. A diameter is a chord that goes through the center of the circle. It happens to be made up of two radii. A secant is a line, a segment, or a ray that intersects a circle twice, and it extends beyond the circle on at least one side. So here is an example of a secant. And a tangent of a circle is a line that intersects a circle exactly one time. Okay, so now that we've talked about these different segments and lines, including tangent, let's talk more about tangents. Draw two circles that have the given number of common tangents. So two circles that have exactly 3 common tangents. That would look like this. It would be a circle right up against another circle. They share exactly 1 point. There's a tangent right there. There's a tangent right there. And then, because these actually only touch in exactly 1 point, there's a tangent right there. Two circles that have 4 common tangents. Those would be two circles that are separated. So there would be a tangent here, a tangent here, and then one here, and one here. Four common tangents. Two common tangents, those would be two circles that intersect each other in 2 points. So you would have a tangent here and a tangent here. But if you tried to go down the middle, then it would touch each circle 2 times. And two circles with 0 common tangents, that would be one circle inside of another. You cannot make any common tangents for those. So here we're going to find the value of x, and AB here is a tangent, and I know that because a tangent is always perpendicular to a radius where they meet. So there's a right angle right there. Okay, so we've got 2 legs right here, x squared plus 48 squared equals AC, the hypotenuse, squared, 80 squared. Okay, so we'll do 80 squared minus 48 squared. So 80 squared minus 48 squared is 4,096. So x squared equals 4,096. And we'll do a square root of both sides. Okay, so the square root of 4,096 is 64. So x is equal to 64. Okay, then our last tangent problem, we are once again finding the value of x here, where x is a radius, and we've got another x here that is also a radius. So these will be the same, and it is perpendicular to AB, so that means AB is a tangent. Okay, so we have the 2 legs, x squared plus 32 squared, and that is equal to the hypotenuse, which is x plus 16. So x plus 16 quantity squared. Okay, so 32 squared is 1,024. So we have x squared plus 1,024 equals, and then x plus 16 squared really means x plus 16 times x plus 16. Okay, so we will distribute x times x is x squared. X times 16 is 16x. 16 times x is 16x. And 16 times 16 is 256. So we have x squared plus 1024 equals x squared plus 16x plus 16x plus 256. Okay, so let's subtract x squared from both sides. And those cancel on both sides. Let's also subtract 256 from both sides. So we have 1024 minus 256, and that is 768. And then on this side we have like terms, 16x and 16x makes 32x. And we can divide by 32, and we get x is 24.